All right, let's go ahead and get started, everybody. Is it showing up there? Okay. So afternoon, and let's go ahead and jump in. Thanks for joining us this afternoon. The agenda that we're going to talk about and dive into is threat hunting and a team environment. And the research that I'm sharing with you, it's a collaboration between the organizations represented there, which is Open Cybersecurity Alliance. That's where all the code lives, and that is a part of OASIS, which is an open standards body. Red Hat, Colorado State University, which I'm a graduate student at CSU, and IBM Security. So one of the things that CSU does with their Doctor of Engineering program is they have a practicum and they have a dissertation as part of the doctorate. And so Kestrel as a service that we're going to talk about is part of my practicum for them. So one of the things that I want to highlight, this is the abstract from today, but one of the key points that I'd like for you to have as a takeaway is that 80% of issues or threats fall under security operations centers with their automation, but there's also the more sophisticated threats that may be hiding for the 20%. And so the root discussion or the root problem that we're going to be addressing today is the mean time to detect. How do I improve finding issue or incident that's occurring in my environment? I know everybody was at lunch, so no sleeping allowed today. My name is Kenny Peeples, and I'm a Red Hat principal architect. My background is around cybersecurity and leading the effort on Kestrel as a service. I'm the VP and the NCOC RAMS, which is a student organization for international systems engineering, and also representative on the Graduate Student Council. So I'd love for everyone to link up with me if you'd like to connect with me on LinkedIn and ask any questions. I'll be glad to connect with you and answer any questions that you may have. And one important thing that we want to keep in mind for October is it is Cybersecurity Awareness Month. And so I like what NIST does in the month of October for cybersecurity awareness. So with this slide, I wanted to show the new logo that I created not long ago. I'm trying to clean up more of the repo. So if you go to the Open Cybersecurity Alliance website, and I'm going to go ahead and show that quick. I know this is jumping around a little, but hopefully you see that okay. I did put the PDF out there for the presentation. So you know, if you want to follow along, please feel free. So let's hop back over. Did it come up? No. Let's do this. So with the mean time to detect that we were just mentioning a minute ago, this is the high-level goal of the research. And the hypothesis is we can improve the mean time to detect of an incident by having crowd threat hunting. So as we dive into this, I'm going to show you an example of how you can deploy Kestrel as a service to your laptop on a single instance of a container platform, or you can also deploy to a full cluster. And so as you can see in this diagram, we have the NIST cybersecurity framework and the core functions. And what we're concentrating on today is the detect, respond, and recover. So the quicker we can find an incident and detect it, the quicker we can respond and recover. And so the types of questions are that we want to ask: can we improve or decrease the detection of an adversary that does minimize that impact? And can we speed up that response and recovery through automation? And the answer is yes. By using Kestrel as a service and OpenC2 and some other components on a container platform, we can speed that up. So it's a secure, scalable, persistent, collaborative environment that we're going to be looking at. And we'll talk about some of the technology here in a minute and what open source projects it includes. So you can go download and install Kestrel by itself, which we'll also cover in a minute, but that's a single threat hunter. So with doing crowd hunting, we can improve that detection time. And so I'm going to keep going. Anybody wants to ask questions, feel free. But I'm going to keep going because I want to get to the point where I can show you how to deploy Kestrel as a service. So just briefly, when we think about threat and hunt intelligence versus threat hunting, we mentioned a minute ago a security operations center automation may find around 80% of issues or threats. We're concerned with that other 20% that's around threat hunting and creating hypothesis. So as it shows here, threat intelligence, evidence-based, looking at attempted or successful intrusions, but we're going to focus on the threat hunting, picking up where that intelligence ends, and looking at threat indicators and hypothesis. So looking at different triggers, IP address, unusual network traffic, but thinking about how we can tie those anomalies back to what is occurring, what the threat is. So we'll dive into that a little bit more as well. And I'm trying not to walk around and mess up the camera. So with the Kestrel as a service components, I want to highlight a couple. And when you look at that repo that I shared, there's a lot of technologies in there that we've included, and I've tried to minimize the manual work. So when we look at these different components, we have Kestrel, which is really the core of what we're using because it is a cyber language and runtime, threat hunting language and runtime. There's a Docker file that I created, and that Docker file, the image, is actually what is spawned up for every threat hunting project in the system. And so the goal is a team of, say, 5 threat hunters using one threat hunting project so that you can start a hunt, you can tie steps, you can do hunt flows, and you can tie all that together and leave it, come back, keep it going, and that Docker image that spawned is in the repo. So you can grab it and actually be a single threat hunter. But our goal is threat hunting with a team or multiple teams. And the goal is to help enterprise organizations improve that detect time that we mentioned. So OpenC2, I won't go as much into that, but that is a way to, there's a more complex example that I share that is on YouTube. And OpenC2 is a way to orchestrate and automate these responses with Kestrel. So you can see an example of that. Stick shifter will also highlight, which is being able to take data sources and turn the data, the cybersecurity data, into a standard that you can look at patterns and then get responses to use within the hunts. And so Kubernetes, hopefully everyone is using Red Hat OpenShift, but I'm going to show how to use Minikube, which is a single instance, a single node of a Kubernetes or a container platform. The code also works against a full cluster, so multiple control planes, multiple workers, but the example today is for a developer environment. Then we have infrastructure, and I included Vagrant and VirtualBox because I can change some of the Vagrant file, and I can either spin up one VM that's Ubuntu and put Minikube on it. I can spin up a Railbox, put Minikube on it, or I can spin up multiple virtual machines and have a full cluster running on it. So the code is easily modifiable to deploy the container platform. So then we have Ansible Core, and Ansible is an easy way to automate configuration. And so all the playbooks are also in the repo. And then Keycloak, which is something that I've had working, but I have to get into the automation, and that allows the external system for authentication in the environment. So one of the things with Kestrel, as I said, it's a specific language that you can go and see the reference on the different commands, how to use it. We're going to show a Hello World example, but you can definitely go and learn more about it. I have a Hello World example, intermediate example, and then a complex example with Purple Team and how some additional components are used. So Kestrel, it came from the start of it, came from ARFL, which is Air Force Research Laboratory, and DARPA, which is Defense Advanced Resource Research Agency. So the two projects at DARPA were transparent computing and the cyber hunting at scale. So those were the basis for Kestrel being built. It is an open source, and you'll see it on the Open Cybersecurity Alliance website, site, when you go look at any of this for Kestrel and Kestrel as a service. So as I said, Kubernetes, it's really nice to be able to go build these containers like the Kestrel container for the language and runtime, tutorials, analytics, all in a container that's easily deployable to a container platform. And so within here, you'll have Minikube and the full cluster, but you can also use OpenShift, which is the enterprise container platform, the PaaS. All right, so Stick Shifter, as I mentioned, it's an easy way to pull together this data for the federated search engine that's within Kestrel and that container. So I can connect to different back-end data sources, and I have a standard way to take that cybersecurity data, create patterns, do certain queries, and then when I get the observations back, I can use those within the Kestrel language to start my threat hunting. And with our threat hunting, it is hypothesis-based, so it is human intervention, more human intervention than a SOC with a lot of automation. And so as this shows, Stick shifter allows connection to Elastic, IBM products, Amazon, Microsoft products, etc. And so Kestrel is using this to be able to pull together some of its data. All right, so JupyterHub, when you look at the code and what's out there, JupyterHub is used a lot with data science and being able to build these Jupyter notebooks. And so the examples I'm going to show is putting the Kestrel language commands in a notebook and executing it. And JupyterHub has a nice way of allowing collaboration with these notebooks. And that's how we're building Kestrel as a service. And it is also an open source product, and it's based on Python. And so this lists the 4 subsystems within JupyterHub. And so you can go back and learn a little bit more of JupyterHub, but that really helps with running the playbooks with the runtime and collaborating. And I'll show how that looks in Kubernetes. So we won't dive deep into the terminology, but I put the links on the slide. So when you go download the PDF and look through these slides, you can go back and reference these. But the main keys here are record or entries from logs. Entities can be IP, process files. The hunt is our discovery procedure, getting our hypothesis and building out our commands. Then our hunt steps are individual hunting operations. And then we have a hunt flow that's a business logic of a hunt. And we put all this together in a hunt book that's within Kestrel as a service that we execute. All right, so some important key concepts is the entity-based reasoning, which I mentioned, and we want to be able to pull those entities together like malicious processes and malware, etc., so that we can build these composable hunt flows. One of the things that you'll notice here in this diagram is a way to build these different hunt flows with the different steps and different hypotheses. So collaborating is very important to be able to pull these together with a team and execute them. So as I mentioned before, it's very important to be able to improve that detection time, and this allows teams of threat hunters to share snippets and be able to do that. So this is similar. So if we hunt faster, we find incidents quicker. And this goes to tying it to crowd threat hunting. And so with our tactics, techniques, procedures, these TTPs, we want to look at indicators. And as this mentions, and those can be network changes and sending data to external command and control systems. But we want to correlate this hunt faster to the stick shifter, and which pulls data sources together, and the mean time to detect. So the first 3 mention things that you don't want to do, which is really more of individual threat hunting items. And then the other 3 are improvements to be able to collaborate on threat hunting. So the Kestrel language itself, one of the advantages here is to for a human to express in a language what should be done on what to hunt. So the 2 main components that I mentioned of Kestrel is Kestrel language and Kestrel runtime. So the Kestrel language allows, as it mentions here, different items such as expressing this knowledge that we have as a human into the patterns, analytics, and hunt flows to build that out in these hunt books and make them so that they're reusable. So we all like, if we're a developer building code that's reusable, here's no different. We want to build a hunt that is reusable steps that can be shared and reused in the future and not reinvent the wheel. And this talks about the data representation. So a lot of the concepts we're talking about are abstractions, and we have these different data and intelligence sources that we pull together, and the logic that we're talking about in these analytic hunt steps. And as it mentions in the last bullet point, reusing and sharing individual steps, hunt flows, and entire hunt books. So that's how we're going to improve this mean time to detect. And so as we go into the Kestrel runtime, this is looking at how to hunt. So we're taking that out of the threat hunter and letting that runtime on JupyterHub and the container platform do all that for us. So as it mentions here, compiling the what against specific platform instructions, so the language itself. Executing that compiled code locally and remotely. So we'll do a hello world so you can see how the language works, but the more complex ones, you can go and look at the videos and try yourself. And then it says here, assembling raw logs and records into entities, the caching of this data, and getting related logs. That's one of the things that StickShifter helps in gathering these cybersecurity logs and entries together. And then we have these different interfaces within the runtime that are used. Awesome. So I was hoping to get to this part so I can actually show you a couple of things on how you can use it. And if things aren't showing on the screen properly, because I'm going to switch to different views, then let me know. I'm going to switch around to visual code and some other things. So we're going to switch from some slides over into what's running and what I deployed. And deploying this is probably less than an hour, maybe 45 minutes when you go start to finish. But I'll show you the steps. And you should have a Minikube Kubernetes platform running easily, along with all the Kestrel components, and can start using it. So this will show you how you can try it out. So I did this diagram, and it pertains to, when you see on the right hand side, the infrastructure build. This one has multiple VMs there for control plane and data plane for a Kubernetes cluster. But if we start on the right hand side at the top, you have the link to Open Cybersecurity Alliance, where you can go and look at everything that I've built so far. And multiple people have contributed and tested as well. But we want to clone from GitHub all of the code, and there's documentation, and I'm updating it daily and weekly as much as I can. But I have the Vagrant file, which can build out Ubuntu or RHEL for Minikube. Then I have a controller VM, which is really the virtual machine with Ansible to run the configuration playbooks. And so I run Vagrant up, and I'll show more of the steps in a minute, but I run Vagrant up to create, in this case, we're going to show 2 VMs, the Ansible controller and the Minikube that's running on RHEL. And also we'll mention Red Hat Developer in a minute if you want to go download a RHEL system and subscribe on the developer account. So then we have our Vagrant up that will create those, and then Ansible playbook provisions. Whoops. All right, so a couple of things to keep in mind, and I'm going to see if this will. Come up over here. Come up. Thank you. I don't want to duplicate screens because then it won't be as easy. So with the Red Hat developer account, you can go subscribe and you can create your own RHEL system, up to 16 of those, as a no-cost developer subscription. So when you go to production, of course, you have to pay for a subscription, but this allows you to have a developer environment. So we can switch back over. Yeah. So the second part is, I'll go through these real quick before I switch over. But for our VS Code, it's easy to pull up all the different types of code that I'm working, and Ansible playbooks or the Docker file, or scripts or anything else. There's a lot of plugins you can use in VS Code. Then the Docker file I mentioned, the image actually gets put out on JupyterHub, and with Vagrant and Vagrant Box, the Ansible controller I created as a Fedora system, and that's out on the Vagrant cloud, so it can be used, and you have a Ansible controller. The customizations, that's in the Vagrant file if you aren't using existing architecture or virtual machines. You can change the Vagrant file to do the different versions of Minikube and the cluster. Also, the Ansible inventory you can change if you have existing infrastructure to deploy to infrastructure you already have. And some of the things I have to go back and test is the full production cluster installation. Because I tested with both Ubuntu and RHEL, there is OS family checks within the Ansible code. And so I had tested the full cluster, tested the Minikube, and I have to go back and test the cluster again, to make sure that everything's working properly when you change inventory or Vagrant file. So on the developer deployment that we talked about, I listed all the steps, which are also in the PDF. One, if you're going to build your own infrastructure, you can use Vagrant and VirtualBox, like I mentioned. And then the best way is to clone the repo and run Vagrant up. If you already have your own infrastructure, I would still recommend using the Ansible controller I have, because you can change the inventory file to point to a single instance to do Minikube or multiple VMs to do a full cluster. And so this step is mentioning after the Ansible VM is ready, you just run controller setup to set up Ansible, and then you do deploy Minikube, which will deploy Minikube onto a virtual machine. And so let's go over to what it has here. Now, I went ahead and included in the PDF some screenshots, which are two, and we'll switch over and I'm going to browse over to what was created, and hopefully everything works correctly so I'm not embarrassed of it not working. But this screenshot is your container platform, and you'll notice it has the deployments, pods, etc., all green, which is what you want. And this is within the Kestrel as a service namespace. So everything is deployed into that namespace when you go through those steps I just went through. Then we have the Kestrel as a service itself. When you browse to that, you have the Kestrel as a service console, and you can sign on, choose the threat hunting container, and then you can enter into the notebook your hunt book. And this is an example of a simple hello world. This is just showing an example of creating processes and doing some commands against the processes that I created. Now this is showing a very simple example, so it's not connecting to a backend like stick shifter with this example. This is mainly to show you two things. One, what I can do with the language, verify that it works, and then testing the runtime because I can execute it, and as it shows here, I'll get data back. So this is not a very complex example. To go on to a more complex example, these are in the tutorial. These help you find connected entities in this example, and this is more powerful because I can look through the backend data that I'm getting for a list of processes and find their parent process, or look at different connections that they have across the network, and finding files that have been that it's reading or writing by those different processes. So I'm not going to go through that one. That becomes a little more involved. And then this one as well. So this was at Black Hat, and a couple of IBM security folks presented this. And so this is within Kestrel with what they were showing, but applies to Kestrel as a service. But as it mentions here, it's using STIX, the structured threat information expression standard, and that is within stick shifter to get results. And then it's using Kestrel, even OpenC2 to do some automation on the response. So that's a YouTube video if you really want to dive into a more complex example that IBM Security is doing. Take a look at that. All right, so I'm going to come back to that. So let's go over here. So on the bottom of these steps, it lists the link for the JupyterHub or Kestrel as a Service console and the Kubernetes console. One's running on port 30,080 and the other's on 30,081. So of course you have to be careful of firewall on your system. And that IP is what, or those IPs are what's selected already in that vagrant file. And so let's go out here. And hopefully that's showing up. Let me do this real quick. So I can move it back over. Tell you what we're gonna do, make it easier. Oh, it's still up there. Did that come back? Yes. Okay. What I'm gonna do to make it easier so that I can see it as well is I'm gonna duplicate my screen instead of extend it. Let me finish up a couple of slides and that'll make it easier. So what I'm going to highlight is this hello world and what I have running. So let's talk about this summary or what's next, because I want to describe some of the things that I'm still working on, and I'm going to pull up the console. So we have within these milestones collaboration settings that I'm going to be working on with JupyterHub. We have the key cloak settings, and I've already done these, but I need to get them into the automation because I want people to deploy and then go browse and everything is set up versus having to do a lot of manual steps. And so also the OpenShift deployment, I want to make sure that's automated, the security hardening with compliance as code, and community hunt books from some of the examples that are already out there. And any that want to get involved, I encourage you to go out to the Open Cybersecurity Alliance site and get involved not just with Kestrel as a service, but there's Kestrel, OpenC2 falls under Oasis, which OCA is under, there's Stick Shifter and other things. So let me come over here. Hopefully this doesn't mess you up if I change these to duplicate. How's that? Okay. All right. So this will make it easier showing you in the browser. So as I mentioned, you can look at this screen for the no-cost RHEL developer subscription. The way that the Minikube deployment is set up now, it uses RHEL, so you have to subscribe with the subscription manager register and auto attach, but you can change that to use Ubuntu if Ubuntu is your preference. So you'll see here I already registered my Minikube RHEL system. And out under getting started, this is where I mentioned that the PDF is located. If you want to go to GitHub Open Cybersecurity Alliance, it has the PDF and just a couple of things within the repo. This is a Docker file that I mentioned, so it builds the container that is run within JupyterHub. And then the deployment scripts that are mentioned in the steps. We have our Vagrant file, our controller setup, deploying our Minikube, and our inventory file. Also in here, I use Packer to create that Ansible controller VM. And so let's go over here to, it was 192. Oops, 168. This would be 6 because it's RHEL. So this is going to give us the JupyterHub screen. Let me jump over here real quick. So in my Visual VS Code, and I'm going to post this out on the web, on the GitHub as well, so that when you're running through, you can see the output that I received. But you'll notice this indicates it deployed JupyterHub on Minikube on that VM. And so we know when it completes with 0 failed, then I can come over and I can browse to my login and do like Peeples 2, and we're going to find out whether it works or not. I'm going to choose my Kestrel threat hunting on Kubernetes, and it's going to spin up the threat hunting project so that I can collaborate with others. And there. Good. So here I have my notebook. I'm going to choose my Kestrel notebook. Come over here so I can grab the code. Here. These are different threat hunting steps, but it is my hunt book. I'm going to copy here. I'm going to execute it. And of course it errored, and there's an invalid character somewhere. So let's do this. I may have to go grab it somewhere else. I want to make sure that I don't copy anything over wrong. Yep, still an error. Yeah, one of those have, give me just a second. I copied it from the slide. Let's go over here. Make sure I have raw. And let's make sure I can grab process. I have to go over to the tutorial. Oh, we're getting close on time. Let's see, line 2. Where's that field statement? Let's look over here. Give me 1 minute. I really want this to run. Oops. I'm going to go grab here. This will also show you how you can do testing if you don't want to deploy to your Minikube environment, but just want to run through testing some. We can come over to Kestrel, and you can see additional recordings. But let's go down to our tutorial. I may possibly use some of CAS here to run it in a cloud test bed for folks to use also. Right now this is using Binder. Let's see if it'll come up real quick. So we have about 5 minutes. Come on. While that's coming up, the other thing I want to show is over here. And this is a Kubernetes platform. And let's go to Kestrel as a service, and you'll see that we have our deployments and our pods. Let's see here. And you'll notice I have the containers that I mentioned that are spawned for every threat hunting project. So Kubernetes and JupyterHub are working nicely together. I can find that. Oops. Nothing like a live demo. So I did a copy, and I'm not sure. I have to look, see which one of those characters it does not like. Oh yeah, it did. Let's try, but I thought it was up at the higher. Yeah, it's up at the higher. Yeah, and this is not going to do it in time. I have 3 minutes left. So let me see if I can. I had it saved. Let's go back here. It should have saved over properly. Yeah. Yeah. That again. One of these invalid characters, it shouldn't be coming up like that. Oops. I'm going to try one more time. And then we will wrap up. So at this point, JupyterHub's running fine, Kestrel containers running fine, Kubernetes running fine. I think it was when I copied over. When I copied over the code, it didn't like what I copied. And so let's one more try. Where is the here? Let's go here. Let's see. Let's try this. Probably gonna do the same thing, but there we go. Somehow I copied something wrong. So thanks for bearing with me. So this is just showing how to use some of the commands. As I said, very simple. So we're not showing a lot there, but we're proving language is working, JupyterHub's working, Kestrel's working. Now we can tie it to, I'm gonna do this here. Then we can move on to tying it to our stick shifter, our back end, and do more complex activities in threat hunting. And so I'm going to see if we can get that. Yeah. So this is coming back, and it's going to be duplicated a little bit. But the key here is I can go look at the language. I can go look through some of these tutorials, and I have a collaborative environment. And it's 1:50, so I think we are done. I will come back here and there. Thank you everybody for showing up, and I enjoyed the session with everybody, and have a good day. And done. Thank you.